Hello everyone, today we're going to go over some Blind 75 C++, and today we're going off the problem house robber. And to save on everything else, I'm just going to give you the most optimal space complexity solution, and it's going to be pretty efficient time complexity, but we will see about that. So, full breakdown, we got our input, what, data structure / algorithm, / technique to use, what to do with the data, and then what our output is going to be. So, be able to give a breakdown of what we need to do. I'm just going to put all the comments so that way we can fully understand the problem we're working with. Alright. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums, alright, so we already know. Representing the amount of money of each house. Return the maximum money you can rob tonight without alerting police. Alright, so we are given an array with an output of 4, and rob house 1. How many houses can you rob without alerting the police? So, let's go over example 1. So example 1, 2, 3, and 1 is that we have a nums to start with of following houses. And the reason why the output is 4 is because robbing house 1 equals money 1, and then robbing house 3 equals money 3. You can total amount you can rob is going to be 4 for money. And let me see. Right, you can return that much of money. Okay, so we're returning the maximum amount of money we can get. And then robbing house 3, house 1, 2, 3. And for this following problem, we're going to stick with dynamic programming, where it's going to expand upon the relationship of set variables as well. Whenever we have already set in place, so instead of taking the whole problem by the whole, we're taking it bit by bit for each variable. So for example 2, just fully expanding upon this, we have 12 as our output. So we can rob house 1, have money 2. We can rob house 3, which would be 9. Rob house 5. We can rob them next to each other. We instead can rob them apart from each other. And rob house 5, which would be 1. We add them up all together. Okay, so it looks like what we're going to do with the data is that we will create 2 variables, preview 1 and preview 2, to keep track of the max amount of money that can be robbed up to the current house. Then we will loop through each house from the first, so we'll treat this like an array. But before then, let's do this. We need to edge case if the array is empty. That will return 0. If the array has 1 house, will return its value. Alright, so we will loop through the array first. And then while we are doing that, for each house, we're going to calculate the maximum value we can rob by either robbing the current house and the 2 houses before. Plus num, preview 1, and then preview 2 is going to be equal to the temp over here. Finally, we will have our output. Turn preview 1. Alright, it passes all the test cases. Let me just clean this up for you folks so you folks can see the entire thing all together. Okay. Here we go, and it passes all the test cases, and it's pretty darn efficient. So, to be able to give a breakdown on what the time and space complexity is, so our time complexity is going to be constant, where n is representing the number of houses. This is because we iterate throughout the list of houses once. And then the space complexity is going to be linear O of 1, as since 1, we're not using a data structure to be able to store everything. We're just scanning throughout the array. And we're only using 2 variables to keep track of everything. So yeah, this was House Robber on Leetcode in C++. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. If you have any other questions in mind, feel free to put them in the comment section. And as always, take care. Cheers.